Okay, so we're going to be doing LeetCode 1249, minimum remove to make valid parentheses. So you're given a string S of characters, these two opening and closing parentheses, and lowercase English characters. And your task is to remove the minimum number of parentheses in any position so that the resulting parentheses is valid and return any valid string. So for a parenthesis string to be valid, if and only if it is an empty string or contains only lowercase characters, or can be written as AB, whereby it's covered with a closing parenthesis, right? Or it can be written with one closing parenthesis with one character in between them, or a string in between two parentheses, right? As you can see here, this is valid, but this is not valid because there's no opening parentheses, right? So the way we're going to do this is we're going to have a stack that is going to keep track of the indices of the invalid parentheses, and then we'll iterate through. We'll create, first and foremost, because the result we're returning, right, is going to be a string, right? Meaning we have to manipulate the string. So the first thing we're going to do is to create a stack. Create a list, right? Because a list of these can be manipulated. And how do we manipulate? We remove these invalid ones, for example, here, by making them an empty string, right? So let me write down the code and you'll understand it. So we create a list out of S, which is our string, so that it's manipulatable, right? So we'll call it result is equal to list of string, right? Then we create a stack to keep track of the invalid open parens, right? Indices. So this stack is going to keep track of the opening parentheses indices, the ones that are invalid, right? So we'll call it stack is equal to that, right? So we iterate through our result list, and we pop off, we add to our stack whenever we find whenever we find an open paren, and pop off the stack if it is not empty whenever we find a closing paren, right? We're going to iterate through this result list, and whenever we find an open paren, we append it to the stack, and if we find a closing paren, we pop it off the stack. We pop the opening paren off the stack because it means that is a valid opening paren, right? But if we find a closing parenthesis, but the stack is empty, it means that closing parenthesis should be eliminated from our result, right? And then once we are done, all we'll have is a stack that is comprised of invalid open parens, right? But they are indices, right? So I'm going to show you how we do this, right? So let's iterate. Let's iterate through the result. So we're cleaning up our result basically, right? I.e., clean up our result. So for index and car in enumerate result, right? So we're returning the index and the car while we enumerate result. I think the n isn't there. Okay, it is. Let's do this. Enumerate result. I think that's how it is. We'll figure it out. Okay, that's how it is. Enumerate result, right? So this will give us the index we found a character at, right? So what we do is we add to the stack if it's a paren, right? And at this point, we don't know if it's valid or not, right? So if car is equal to opening paren, then we add it to the stack, right? So stack, we add its index. We add its index to the stack. So stack dot append idx, right? That's why we use the enumerate, right? Elif car is a closing paren, then we check whether our stack is not empty. Why? Because if it's not empty, then that means it contains an opening paren, which is related to this closing paren, and we pop off, right? So if stack is not empty, we pop off an open paren because we have found its closing paren, right? So we say stack dot pop. Else, stack is empty, so the closing paren we found should be set to empty string in our result, right? So what do? We say result at idx is equal to empty string. You can use empty string or you can use empty car, right? So now once we're out of here, we'll have popped off all the valid. So once we're out here, we have popped off all the valid parens from the stack, and if it is not empty, it is comprised of only the invalid open parens. Or we popped up all the valid open parens, right? Once we're outside of this loop. The other thing is we set, right? We have set all the invalid closing parens to empty string or car. So we've dealt with that. So with this, we've dealt with the valid open parens, right? We've made sure they're not in our stack, and we've left them in the result, but we've popped off all the invalid closing parens, right? So time to remove the invalid open parens from the result, right? So all we do is we say, and this is why we appended indices of parens in the loop. You see here on the stack we appended the index of the paren, right? Of the parentheses, of the opening parentheses. So we say for j in stack, right? Index of invalid open paren, we simply set it to empty string or car, right? So we say result at j is equal to empty string, and then we return. So this is why we're setting them to empty string, because all we're going to do is do a join of our result, right? So when we run this, enumerate. Oh, perfect. So this should work. I hope I didn't make a mistake with this part. Okay, it works. Voila. And that's how you do it. Let me see. I think, do you have to for car? I think, yeah. Yeah, it's in enumerate, right? So this is the solution, right? And the time complexity is O of n, and the space complexity is O of n as well, because we just maintain a stack, right? So that's the solution, and thank you, bye.